The main objective of this activity is to enhance the skills of the students in using Microsoft Excel in creating templates for the following topics. Each topic mentioned earlier will be discussed by the members, inclusion of how does each template works and the scope of the worksheet they created. This Excel worksheet works in computing the root of a given function using the bisection method. Bisection method is under the bracketing methods in solving non-linear equations. It is an approximation method to find the roots of the given equation by repeatedly dividing the interval. In this template, we have the following formulas: the approximate percent relative error and also the midpoint. So let's try to work on this template. We have a given equation here. F of x is equal to x to the fourth plus 3x cubed minus 5x squared minus 7x minus 10. Let's input the following coefficient in the given table: 1, 3, negative 5, negative 7, and negative 10. We put the coefficient in the table, make sure that the other functions are set to 0 which is not in the equation. In the right side table, it will compute for the possible initial values of x and f of x. Going to the bisection method table, we have to input the two initial guesses that corresponds to x sub n and x sub p values. Once the initial guesses were put in the table, it will automatically solve for the following columns that is based on their assigned formulas to solve. Let's try to put some values. Let's try to put 2 and 3. Then, the table will compute for the function of xn and x sub p, and this column will compute for the midpoint of the given interval guesses. The approximate true error is also computed here. For the last part is the judgment, which tells whether to continue or to terminate the solving process. Usually, when the values are constant, this is where the root of the equation lies. So in here, it was in the 34th iteration where the values became constant. So, the root of this equation falls in 2.0900462219. This template caters polynomial equations up to 10 degree and also trigonometric functions, which should be first set into rad. Lastly, log functions.
We'll be discussing bracketing methods in solving nonlinear equations, regular Falsi method. In this method, it is a numerical method for estimating the roots of a polynomial f of x. A value x replaces the midpoint in the bisection method and serves as the new approximation of a root of f of x. The objective of this method is to make convergence faster and assume that f of x is continuous. For this template, the scope is up to 5th-degree polynomial equation. This equation, in this template, we use a 5th-degree polynomial equation, and our f of x will be 2x raised to 5 plus 3x raised to 4 plus 8x raised to 3 plus 4x squared plus x plus 6. For our xn, 2, x and 3, it is depend on the user what number they will be input. To solve for the iteration, xn, just input the number, and for f of xn, substitute the xn to the equation of f of x. xp, input the number, and for solving f of xp, substitute the xp to the formula of f of x. For x new, the formula will be this, and to solve the f of x new, substitute the x new to f of x, and same with the other. And to get the other iteration easily, just drop, and the iteration will be this. Discussing open methods in solving nonlinear equation using simple fixed point iteration. The idea of this method is to first reformulate equation to an equivalent fixed point problem, such as f of x is equals to 0 will be x is equals to g of x. And then, to use the iteration with the initial guess, x sub 0, choose and compute a sequence x sub n plus 1 is equals to g x sub n. For this template, the scope is up to 5th degree polynomial equation. But in our equation, as you can see, x squared to x is 0 because when we put number rather, the table will be error. But when we use the equation x raised to x raised to 5 minus 7x raised to 4 plus x raised to 3, the equation will not be error. Hence, this equation is also a 5th degree polynomial equation. So, g of x will be x raised to 5 plus negative 7x raised to 4 plus 12x cubed times 1/5. xi will be 2, depends on the user. To solve the iteration, just put first the value of xi, then solve for xi plus 1. Just substitute the xi to the equation of g. And then for relative percent error, this will be the formula. And then to get the iteration easily, just copy and then drop, and the iteration will be there. If the user wants to change the equation, for example 3, negative 8, 4, the equation will be different.
Okay, this is Newton-Raphson method, and ito yung formula na ginamit. Ito yung equation natin, then derivation of equation. Ang ating value dito, itong table ay inalagay natin sa xi ay 0.8, and then ang value nito ay galing dito, and dito naman ay dito, at sa x1 ay yung pinagsama na itong mga itong tatlo gamit to, dahil ito ang formula. So ito ang lumabas na value, and then copy para sa bagong value, and then copy ulit to para dito naman, and ayun, copy ulit to, yung diretso na hanggang baba para makuha yung iteration hanggang sa makuha natin na meron tayong 0. So dito pa lang meron na. So yan, tinuloy ko lang hanggang baba.
This Excel worksheet works in computing the root of a given function using Secant Method. This is very similar to the Bisection Method, except instead of dividing each interval by choosing the midpoint, this method divides each interval by the second line connecting the endpoints. In this template, we have the following formulas: the approximate percent relative error, and also x sub 1 plus I. So let's try to work on this template. We have a given equation over here: 3x to the fourth minus 8x cubed minus 37x squared plus 2x plus 40 equals 0. Let's input the coefficients of this equation. Then make sure that the other functions are set to 0, which is not in the equation. This table here will compute for the possible initial values of x and f of x. Going to the secant method table, this column would be the first guess or the first value that we assume, while this column is the second guess or the second value that we assume. As the initial guesses were put in the table, it will automatically solve for the following columns that is based on their assigned formulas to be solved. Let's try 2 and 3. The table will compute for the function of each column, as well as the x sub 1 plus 1, and as well as the approximate true error is computed. And for the last part is the judgment, which tells us whether to continue or to terminate the solving process. Usually, When the values are constant, this is where the root of the equation lies. In the example, it was in the fifth iteration where the root of the equation lies. This template caters polynomial equations up to 10 degree and trigonometric functions which should be set first into rad.
Cramer's rule, a method involving the determinant of the coefficients for calculating a unique solutions for a given system of linear equations. Here's an example. We have three given equations, which means 3 by 3 matrix, and we need to do is to find out the value of x, y, and z. And these are the determinant of d, these are the determinant of dx, and these are the determinant of dy, and these are the determinant of dc. Then we need to find the value of d, dx, dy, and dc. For d, negative 72. For dx, negative 40. For dy, negative 88. And for the last dc equal is negative 240. To find x, y, and z, and these are the formula that we need to use. And let's start for x equal dx rather is negative 40 divided by d equals the value of x is 0.55556. For y liter, and the value of y is positive 1.2222, and for last z equal negative 240 divided by negative 72 is equals to 3.333, and that's all.
So, hello everyone. Ngayon ay papag-usapan natin ay ang direct methods in solving system of linear equation and Simpson rules. So, unahin natin ang direct methods. So, ang papag-usapan natin sa direct methods ay ang x equals to a raised to negative 1 times b. So, ang slope natin is 5b5 matrices with integers as its coefficients. So, ito yung given natin, which is 5b5. And then, so, ang ginawa ko dito is pinaghiwalay ko yung a and b. So, yung equals yung mga nasa b, which is ito. Equals 45, 30, 15, 20, 92. So, ito, nilagay ko dito lahat ng sa left side, which is itong mga to. So, dito naman, para masolve natin yung a raised to negative 1, is, ang gagawin natin is ito. I-drag natin to hanggang dito, katulad lang siya dito sa taas. And then, lagay natin tong equals mean verse. I-drag natin to, itong part na to dito, para masolve natin siya, kasi ito yung sasolve natin, which is nandito, which is ito, C6 and G10. So, nasan bang C6? Ito ang C, then 6, so 11, so right, ito siya. Then, yung dito naman siya, so ito siyang 14. So, ayan, after mo ma-highlight tong nasa taas, mean verse, open parenthesis, then highlight mo to. Dapat ang gawin mo is Control Shift Enter para masolve siya. Kasi pag enter lang nilagay mo or in-enter mo is isa lang lalabas. Ito lang. Then after that, para masolve naman yung final answer natin, which is x. So ang gagawin natin is highlight naman natin to. First gawin muna natin is lagay natin equals to m ult. Then, highlight natin to. After that, lalagyan natin ng comma. Then, highlight naman natin tong B. Then, close parenthesis. The same lang din gawin natin siyang Control-Shift-Enter para masolve. So, ayun.
Discussing direct methods in solving linear equations using LU decomposition. LU decomposition of a matrix is a factorization of a given square matrix into two triangular matrices. one upper triangular matrix and one lower triangular matrix, such that the product of these two matrices gives the original matrix. This method of factorizing a matrix as a product of two triangular matrices has various applications. Basically, the Elliott decomposition method comes handy whenever it is possible to model the problem to be solved into matrix form. In this template, the scope is 5 by 5 matrix only, and the user cannot change the equation because the formula will be different based or in terms of the lower and upper matrix. For lower matrix, the upper right side must be 0 and the diagonal must be 1. The user should get the formula to get all zeros. For upper matrix, lower left side must be 0, and again, the user must find a formula to get this. To get Ly is equals to b, it will get y1 to y5. For ux is equals to y, it will get the value of x sub 1 to x sub 5. For the value, this will be the formula. Note that this will be confusing because equation and problem to be solved depending or in terms of the lower and upper matrix.
This Excel worksheet works by determining solutions in system of linear equations. It is one of the iterative methods used in solving linear equations, the Gauss-Jacobi. Let's work on this template. So if you have the following equations over here, you will input the coefficient of each in this table over here. After entering the values in the table, this table right over here will provide an equation for each value unknown, which is from A to E. This table works on a 5 by 5 matrix. Once the values are input, the Gauss-Jacobi method will automatically update as well. Let's try for an example. Let's try to put the values of these equations to the table. 20, negative 2, 2, 3, 4, negative 1. For the second equation, negative 3, 12, 1, 4, 2, and 2. For the third equation, 2, negative 1, 10, 6, 1, and 3. And so does with the equation 4 and equation 5. Let's put on the table. As you can see, this table, which is the formula for the unknowns, automatically updated. Same goes with the Gauss-Jacobi table right over here. This table will compute for each of the unknown functions given, as well as the approximate percent relative error for each unknown. This worksheet also accepts for the values which is in decimal or fractions, but it can only solve for 10 iterations of the matrix.
So in this template, we're going to use the Gauss-Seidel method. Gauss-Seidel method is a method of iteration for solving linear equation with the unknown variables. This method is quite complex to program, but when done correctly, the process is a lot faster. So as you can see in this highlighted part, this is our matrix or table. We will try to input our unknown values. So let us try to input values 5, negative 2, 3, 3, 6, negative 1, negative 3, 9, 1, 6, 2, 2, 2, negative 1, -7, 6, 1, and 3. So, as you can see, from there, after that, Excel will provide the equivalent equation form that you will put in this Gauss table. So this is our Gauss table. And each unknown has a equivalent absolute error. So how does Gauss-Seidel method really works here? As you can see, it will get a value of each unknown. So in the first equation, it will get a value of A. On the second equation, it will get the value of B. On the third equation, it will get the value of C. On the fourth equation, it will get the value of D. And the fifth equation, it will get the value of E. And then when we get it, we will substitute it here. And Excel will automatically tabulate it. So basically, Gauss-Seidel method works by getting one unknown value in each equation and just substitute it here as its initial value. The scope and limitations of this template are the program or Excel accepts fraction, decimal, and whole number, and it only consists up to 10 alterations.
Ito ang relaxation method. Makikita natin dito yung given, yung coefficient matrix, formula, yung iteration number, kung ilan sila. So dito sa given, tatlo. Dahil lang ginamit ko dito sa matrix ay 3x3 lang. At sa formula, ito ang mga formula. Ayan. And ito naman, iteration number, 10 ang aking nagawa. Then dito, ayan, dyan nagamit yung formula para makuha natin yung value na yan. And then ganoon din sa kabila. Ayan. And ito ang judgment. So kung continue, ito terminate, and the rest continue na.
Is the process of finding the numerical value of a derivative of a given function at a given point. In short, this method is more difficult than numerical integration. And here's an example. We have here 2.fdd, 3.fdd, and for 2.fdd, here's the formula. And let's try to solve this 3.fdd. Given f of x is equals to sin e raised to x minus 1 and x is 3 and step size is 0.1. And for FTD, ito po yung kailangan po natin gamitin na formula. And try this. Need to do is x plus 2h. X plus h is equal plus h. Yun. X minus h, 3 minus 0.1 is equals to 2.9. X minus 2h equal 3 minus 2 times h is equals to 2.8. Using this formula, we have answer which is 0.157, 42, 88, and 42.
Ito naman ay numerical differentiation, central divided difference. And ito yung equation ginamit. Ito yung value ng x, 0 and 1. And then analytical, para nakuha to, yung derivation ito. First degree, second degree derivation, then the third degree. So same din dito. Ganun din. Derivation din yun ang gamit.
So in this template, we will be talking about the backward divided difference, Is this also a method in solving numerical differentiation? So backward differentiation is a method of getting the first derivative of an equation in which the value of the derivative is obtained by reversing the process of its definition. It is commonly used if the future value of the derivative is not yet defined. The limitations of this template is the user must input the equation that she or he needed to differentiate or integrate. Here is an example. Given the velocity of a rocket, use backward difference approximation of the first derivative of Vt to calculate the acceleration at 16 seconds. Use a step size of 2 seconds. So we are asked to solve for the first derivative of velocity using another method of numerical differentiation, which is again backward divided difference. Given this formula that we use when we are computing using this method, and given the xi which is 16 seconds, the step size or change of x which is 2, and when we input the 16 here, there. So to get the fxi, we will just substitute 16 in t or x in this equation, and same goes here, we will use the answer to substitute it as the value of t or x in this equation. So when we evaluate this formula here, when we evaluate the formula here, which is the change xi minus step change divided by step size, then this will be the answer. So if you manually derive it, this will be the answer, which is 29.674 compared to 28.9145. So there's a relative error of 2.56%, which is still acceptable since we still have other factors to consider. The trapezoidal rule for estimating definite integrals uses trapezoids rather than rectangles to approximate the area under a curve. The limitation of this template is the angle of trigonometric function is in radian. I use this equation as an example, such as sin x squared, and then we will get its integral from 0 to pi. We will get the change of x of this equation using our interval 6. And then, after that, we will substitute it here, and it will automatically increase by the value of x, and it's only until 6 since it's our interval. The sum of everything here is this, and it is our area or our answer.
Next is Simpson rules naman tayo. So, short description lang para sa Simpson rules. So, ang Simpson rules is one of the numerical method which is used to evaluate the definite integral. So, ayan. So, itong slope naman natin is polynomial function, fifth degree. So, ayan. Ito yung equation natin. Tapos with n equals to 20. Ayan. Tapos ito naman yung rules natin for Simpson 1.3 and Simpson 3.8. So, yan. Ang equation natin is this, which is ang raised to 5 minus 35 x raised to 4 plus 55 x raised to 3 plus 2x raised to 2 plus 1. Then, ang upper limit natin is ito, 8, plus lower limit 0, which is makita natin dito sa equation natin. It is ito, upper limit and then lower limit. Then next is the number of segments, which is 20, na nandun din sa equation. Itong n equals to 20. Ayan. Then, step size. Paano nga ba natin isolve ang step size? Yung kailangan natin gawin dito is ito yung ginawa kong formula. So, ang ginawa ko dito is upper limit minus lower limit, then divided by 20. So, ayan. Ganito ko siya ginawa. Then, pag in-enter mo siya, ito lalabas, 0.4. Tapos, ang true value naman is ito. Makuha naman natin to sa pamamagitan ng pag-solve ng ating equation manually. So, kunwari, nasagutan na natin siya. Ito ang lalabas. Tapos, ito na yung data naman natin. So n hanggang 20 siya dahil sa number of segments natin, 20 din. So delta x, paano ba natin to isosolve? So sinolve natin to sa pamamagitan ng ayan, sa una, gamitin natin yung a2, which is 0. Then, plus lang natin yung step size, which is ito. Nasa S10 siya. Itong escape, ayun. So, after nun, double click lang natin to. Masasolve siya lahat hanggang 20. Then, next is sa fx naman. Paano natin sa sinolve? Sinolve natin to is sa pamamagitan na lalagay natin dito yung equation natin, which is ito. Then, papalitan natin lahat ng x ng katapat niyang delta x. Ayan. So, ayun. Then, enter. Lalabas siya. Then, double click lang ulit para masolve siya lahat hanggang baba. So, dito na tayo for the final answer. So, itong true value. Then, true value natin. Then, sa approximate value naman. So, gagamitin na natin yung formula for the Simpson. So, ito, for the 1-3 rule. Ito yung gagamitin. So, yung h, ang ilalagay natin sa h is ang step size. Ayan, which is S10 over 3. Ayan. Step size over 3. Then, dito naman dito sa F. Tapos, open parenthesis x0, close parenthesis. Ilalagay natin dyan is yung umpisa ng fx, which is ito. 0 plus yung dulo, which is ito. Then after that, ito, add. Nahanap naman yung mga odd numbers. So, ano ba yung mga odd numbers? So, ito yun. 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. So, nilagay ko yan dito, isa-isa. So, saan ba yung yung mga fx, ilalagay natin siya dito, ng mga odd number. Ito. Then, next is plus 2, which is ito. Then, f. Tapos, ang susunod naman, hanap niya is even. So, ano ba yung mga natira? Ito yan, mga 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Then yun, after nun, enter. Then, ayan, lalabas. So, ito naman, next is to. Paano natin ito isa-solve? So, ang gagawin natin is ito, AH2, which is our true value, then minus our approximate value, then divide ulit natin sa true value, then times 100. Then, ayan, lalabas. Then, next, Simpson 3/8 rule. So, ganun lang ulit natin. So, approximate value. So, ito yung formula. 3h. H is for the step size ulit. So, ilalagay natin dito is yung step size. Ayan, 3 times step size divided by 8. Then, after nun, ang inuna ko dito is yung itong part na to. Para hindi ako mahirapan. So, ang ganawa mo natin is divisible by 3. So, ayan siya. Inuna ko siya. Then, plus 3. Itong part naman na to, yung mga remaining. So, ano ba yung natitira? Which, ayun, nilagay ko ano yung mga natitira na hindi divisible by 3. Then, after that, and approximate value. The next is dito ulit sa percentage. True value minus approximate value, then divided by true value. Tapos times 100. So, ito na yung sagot.
Example. For this example, we need to find the height and the trapezoidal rule and the true value and the approximate relative percent error. Here's a given. 2 ln x plus cos x plus 5x minus 2. Here's the formula given for true value. And the A is 1, B is 3, and to compute height, B minus A over N. To compute the Boole's rule, here's a given formula. Our lower limit is 1, our upper limit is 3, our N or number is 20, and minute N of points is 21, and the height is 0.1. The value of X and the 3 is our upper limit, and the 1 is our lower limit. Then here's the f of x value. Then we have the final answer for trapezoidal rule, which is 15.299649, and our true value is 17.8913, and our approximate relative percent error is 17.0362.